Welcome back. In this video, we are going to solve problem 10-79 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the yield stress for heat-treated beryllium copper is 130 ksi if the material is subjected to plane stress and elastic failure occur when one principal stress is 145 KSI. What is the smallest magnitude of other principal stress? Use the maximum distortion energy theory. So you can see yield stress is given and it is stated that one of the principal stress is 145 KSI. So you have to find the smallest magnitude of principal stress sigma 2. So let's start with the solution. So here we have been given as sigma 1, which is the one of the principal stress, that is 145 KSI, clear, and we have sigma y, and that is equal to 130 KSI. So using maximum distortion energy theory, I will write it energy theory, which states that an object will yield or it will fail when the maximum distortion energy, the equation is sigma 1 square plus sigma 2 square minus sigma 1 into sigma 2, that is equal to sigma yield square. Under this condition, this material will start yielding. So we have been given sigma 1, which is again 145 square, plus sigma 2 is not known, minus sigma 1, which is 145 into sigma 2, and we will get that is equal to 130 square. Okay, so what we will do is that you will get this 145 square. So 145 square is 21025 plus sigma 2 square minus 145 times sigma 2 is equal to, so we will 130 square is equal to 16900. So sigma 2 square minus 145 sigma 2 plus 21025 minus 16900 is equal to 0. So 21025 minus 16900, it will give you 4125. So sigma 2 square minus 145 sigma 2 plus 4120 is equal to 0. So you can see this is the quadratic equation, and we will solve this quadratic equation. So as we know that we have general form of quadratic equation is ax square plus bx plus c is equal to 0, and its solution will be minus b plus minus under the root b square minus 4 times a multiplied by c divided by 2a. So here you can see you have a is equal to 1 in this equation, b is equal to minus 145, and c is equal to 4125. So we will have solution of sigma 2 will be equal to minus 145, because this is minus sign and this is the value of minus b, plus minus b square, which is minus 145 whole square minus 4 times a, and c is 4125 divided by 2 times a, which is equal to 1. So you will get sigma 2 will be equal to 145 plus minus. Now we will calculate this value which is in under the root. So I will take minus 145 square minus 4 times 1 into 4125, and we will take the square root of this, which is equal to 67.268 divided by 2. So here we have two roots. The first one will be 145 plus 67.268 divided by 2, and the second root will be sigma 2 is equal to 145 minus 67.268 divided by 2. Okay, so 145 plus 67.268 divided by 2 will give you 106. So sigma 2 is 106.134 KSI, and the second one will be 145 minus 67.268 divided by 2, which is equal to 38.86 KSI. So here you have two values of sigma 2. One is this one and another one is this one. But in our question, we have been asked to find the smallest magnitude of other principal stress. So what we will do is that we will write the smallest value of other principal stress is 38.86 KSI. So sigma 2 will be 38.86 KSI. And this will be our final answer. So this was all about this problem 10-79. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, please ask me in comment section. Thank you.